right, I'm recording. Good. All right, great. So back to what we were doing earlier. Okay, are we on number 68 now? I think we're on number 68. So this is the implicit differentiation stuff,
We're
right?
67.
We were on 67? Okay.
Yeah.
We can do this, but I feel like I don't want to waste our time doing that one because I feel like you can figure that one out. Just because we've done some of the problems like that. Let's try this one, just so we can cover problems from more spectrums. Okay, how do we do this? Anyone go ahead and just talk about it. Anish, why don't you try explaining this one?
Wait, which one? Sorry, my parents came in.
No, you're fine. Number 68.
Okay.
So we have an implicit and a function implicitly defined, and then we need to find dy dx.
Okay, so I think it's going to be first, we just take the normal derivative of everything. So I'm just going to do 2x plus x y prime, or?
Yep, that's good. Yep, good job.
Plus 2x plus y prime. Wait, it would be just 2x plus y prime plus.
Oh.
Yeah, because x would become 1 anyway.
And then plus 3y prime, I think?
Yeah, 3y squared y prime. Yep.
You guys forgot a part. You guys forgot the second part. You have to use product rule here, right?
Oh, right.
First one times the second, or derivative of the. Actually, I don't think I did this right. It's the first derivative of the first one times the second one plus the derivative of the second one times the first one. So xy prime. And then what do you say? And then 3y squared y prime, right?
Yeah.
And that equals 0. So now you solve for y prime. Okay?
Yeah.
Let's try and do this in our head. Okay? So y prime, I know that I'm going to move the negative 2x and y over to this side. So I'll have negative 2x plus y in the numerator. And then I'm going to have to factor out the x and the 3y squared. So I'll put that in the denominator because I'm going to eventually divide by that.
Yeah.
Okay. Which answer choice matches to that? I think it's A, right?
Mm-hmm.
Okay. I think A is the correct answer for that. Okay. Good. All right, let's try number 69. We're trying to find dy dx at a certain point. All right, let's have Zachary. Do you want to try this one?
Sure.
All right.
So it would be 1.
Yep.
Plus, I have to do product rule there.
Mm-hmm.
So it would be 2x y times y prime is 2x y prime plus 2y.
Good, good, good.
And then minus 2y equals 2.
2y prime, right? That equals 0. I make this mistake a lot.
Oh, yeah.
When you have a constant, when you differentiate, it becomes 0, right? Make sure you keep that into mind. Take that into consideration.
And then you just solve for y prime.
And honestly, what I'd actually try and do is just plug in 1, 1 first. So this will be 1 plus 2y prime plus 2 minus 2y prime equals 0. And that actually makes it problematic for us, right? What this probably tells us is that it's probably going to be non-existent, probably. Yeah. But just to be sure, what I'm going to do, let's go ahead and solve for y prime in that case. And what would that be? That would just be minus 1 plus 2y over 2x minus 2y. And this makes sense because in the numerator or in the denominator we'll have a 0, right? And 3 over 0 is undefined, so that's why the derivative is non-existent. Does that make sense? How we got that? Okay. All right. Good. All right, and this is just more implicit differentiation. Do we want to try more implicit differentiation? Let me know. Or do you want to keep trying the implicit differentiation ones, or do you guys want to move on?
I think maybe we should go to the last topic, the inverse at a point.
Inverse at a point. Or the second tan? Or what did you say? I just heard inverse at a point. Is that all you said?
Yeah, because we covered chain rule, and then we covered the second topic, the implicit. So then there's third, and then the fourth one. I don't know if they have questions from that kind of like from
the real application. Okay.
Yeah. I don't know if they have that.
I can't find any problems regarding the inverse. Can you find any of them on here? I can't find any. Can you guys? I don't think I can, right? Okay, all right. So let's go ahead and stop the PDF right here, and let's just go ahead and search up AP Calculus problems, inverse derivative at a point. Okay. Let's see this. Let's look at this resource and see if it helps. Or like, let's see if we can get some practice problems. Will it have rates of change in particle motion? I think it will. We'll talk about that in a bit. Okay.
I have one quick question before we. It's like a really basic question. Whenever we're finding a vertical tangent, that's whenever the denominator is 0, so the slope is undefined, right?
When the denominator is 0, but the numerator isn't 0. That's really important.
Yes. And then if it is 0, then that's indeterminate form, and you have to. That doesn't necessarily mean okay.
Yeah.
And then for horizontal line, it's whenever the slope or the derivative is equal to 0.
Yes.
Okay.
Okay. And if it's a rational function, then what you have to be careful is that the numerator does equal 0 and the denominator doesn't equal 0. Okay. All right. Do you guys remember how to do these? If I have y equals tan inverse of root x minus 1, what's the derivative of that? What's y prime? What's the derivative of tan inverse? All right. You guys remember?
1 over x squared plus 1.
1 over, I say 1 over 1 plus x squared. It just helps me remember. But it would be 1 over 1 plus whatever my input is squared. But since it's x minus 1, root of x minus 1 squared, that would just be x minus 1. The minus 1 and the plus 1 go away. So then that's just 1 over x. But then we have to take the derivative of this inside function here. And that would be times 1/2. And then it would be x minus 1 in the denominator, and then the derivative of that, the inside function of that is just 1. So this is essentially equal to 1 over 2x times root x minus 1. All right? Okay? So just make sure you know how to do that. All right. I thought there was going to be stuff about inverse functions in here. Apparently that's not in here. Wait, never mind, there is. Let's try this one. Let f be the function defined by f of x equals x cubed plus x. If g of x equals f inverse of x and g of 2 equals 1, we need to find g prime of 2. Okay, all right. So f of x equals that, right? So what is f inverse of x equal to? Wait, we don't need to know that. We don't actually need to know that. But what is f inverse prime of x? That's 1 over f prime of f inverse of x, right? Is that it? I think that's it, right? Let me think about this. Yeah, that should be right, right? This is the formula. F inverse prime of x is equal to 1 over f prime of f inverse of x. If you don't know this, all you got to do is just remember that f of f inverse of x is equal to x, and then differentiate both sides, and you should get this. Okay, so we are finding f inverse of 2 essentially, right? So f inverse prime of 2 is equal to 1 over f prime of f inverse of 2. And what is f inverse of 2? F inverse of 2 is just 1. So we're trying to find 1 over f prime of 1. So what is f prime of 1? Well, we know f prime is equal to 3x squared plus 1. If we plug in 1, we get 3 plus 1, which is 4. So this is 1 over 4. The answer is B. Does this make sense how we did this?
Yeah.
Cool, cool. All right. Let me see if I can find some more problems like these. That might help. These you just gonna have to use the rules. I'm looking at more of the. No, it's none of this stuff right here. Let's try this one. Oh wait, is this Miss Rogers? I have a feeling this is Miss Rogers. Yeah, I think this is Miss Rogers. Yep, this is Miss Rogers. Okay, this is the one we did for homework. See if this Ghosh site has something. And then for the rate of change ones, we can just go through the practice problems and see which ones for them. Okay, perfect. Let's look at this one. Hopefully you can see it. Do you need me to make it a little bit bigger, or is it good? Let me make it a little bit bigger. Okay. So let's say, okay, so this is that. G is the inverse, so that means G prime of x equals 1 over f prime of g of x. So if I'm trying to find G prime of 13, I don't know why I wrote 2 here, that should be an x. G prime of 13 is equal to 1 over f of f prime of g of 13. How do we know what? We would have to solve for the inverse of this. Okay, we need to figure out. So ideally, they would give you G of 13, but they don't give that to you in this problem. Oh, they just use trial and error. Okay, so by trial and error, if we can just think of a number that when you add it, it equals 13. When x equals 1, 3 plus 6 is 9 plus 4 is 13. So the answer is 1. That means this is essentially equal to 1 over f prime of 1, right? Because g of 13 is just 1. So now to find f prime of 1, Zachary, did you have a question?
No, do we have to solve it then? Like, if we don't get g of x, do we have to solve it?
You would have to solve it, but it won't be something complicated like this. You won't be asked to do that. That's usually not reasonable. And if they do ask you to do it, it's usually a simple number like 1 or 0 or 2. So it won't be something crazy. Okay? All right. F prime of 1, this will just be 5 times 3 is 15, x to the 4th. Like if I take f prime of x is equal to 15x to the 4th plus 18x squared, and that's it. And if I just plug in 1, then that's just 15 plus 18, which is equal to 33, I think. So 1 over 33 would be the answer, I believe. Mohammed, does this help? Or do you want to do more? We can do more if you want to.
That helps. Yeah, that helps. I was just like saying it because I was like, maybe we should go in order.
Oh, sure. Okay, does anyone else want some help with inverse derivative of inverse stuff, or do we want to move on to the last topic of rates of change?
Do we have to know how to do this stuff from that mixed problem sheet?
The mixed problems stuff? Honestly, once
test?
I don't know what she's going to put. I don't think she would put it on the test, but those concepts you need to know because they get used over and over and over. Like if someone's giving you position and they're asking you to graph velocity, you need to know how to graph the derivative of a function just given the sketch, or sketch the derivative of a function given the graph. You understand what I'm saying? Like that was a skill in the mixed problems, but those are things just you need to know how to do over time. Okay. All right. Do we want to try some of those problems from the rates of change?
Sure.
All right, let's do that. Okay, which ones do you guys want to do? Do we want to try one of these example problems? I think one of these would be helpful. Actually, let's start. Let's answer these questions really quickly. Okay, let f of x be the elevation of the Mississippi River x miles from its source. What are the units of f prime of x? Okay, hold on. So what is f of x in general? F of x, it's units. What are f of x's units?
It's, I don't know what. Oh, miles. So
feet. X is miles, but f of x is feet, right?
Oh, yeah.
So what are the units of f prime of x? Remember, derivative is just slope, so it's y over x. So what are the units of y over x?
Feet over miles.
Yeah, feet per mile, exactly. Okay, well, and what about the sign of f of x?
Positive.
Well, let's think about it.
What?
As you get at, okay, so this is where you would have to maybe do a little graph. As you get, if this is the source, right, of the Mississippi River, as you get further and further away from the source, the elevation has to drop, right? Right? As you get further and further away from the source of a river, the elevation must be dropping, right? Does that make sense?
How do you know that?
Well, I mean, that's just, I guess, I mean, I might be wrong, but that's just the logic that I came up with, because if like, that's just, like, that's why we say a river flows downstream, because it's going down.
Oh, okay.
Yeah, because like just logically thinking about it, if I have the source of a river here,
like that.
Yeah, no, I never thought about it until I did this problem either. But if a river starts at the bottom of a hill, there's no way it's going to be able to go up the hill, right? So it has to start at higher elevation, then go down. So this must be the way, it must be, f prime of x must be negative. Okay? All right. An economist is interested in how the price of a certain item, okay, blah, 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 blah. Okay, so essentially we're saying f of p, or quantity, is a function of price. Okay, so what does this mean? F of 150 equals 2,000. That means at a price of $150, 2,000 items are sold. Does that make sense?
Yeah.
Okay, what about this one? Remember, you're always, as soon as you see a prime, it's a rate of change. That means at a cost of $150, right? At a cost of $150, the quantity of items sold changes at a rate of negative 25 items per dollar. Okay, it's a very simple formula. This is what you're going to say. At a x value of what, so I'm writing x value here, but that's, or this is the, I'll say IV for independent variable. At a independent variable of x value, the dependent value, or dependent variable, changes at a rate of f prime of x dv units per IV unit. Okay, what does this mean? So let's make sense of this. At a cost, right, because cost is the independent variable, at a cost of $150, the quantity of items sold changes at a rate of negative $25 per, sorry, negative 25 items sold per dollar. Does that make sense? It's just a formula, essentially. Every type of problem where you're asked to interpret the meaning of a rate of change, essentially this is what you're doing. You're just plugging it into this formula. Okay? All right. I think we should do, hopefully this makes sense. I don't want to go, I feel like you can figure out the rest of it. I want to try one of the particle motion problems. Let's try one of the ones in the example. I feel like they're better to explain. Let's try this one. Okay. And here I want you guys to unmute yourself if possible, and I want you guys to speak up because I feel like this needs to be a collaborative learning part of this part, right? So when is the particle moving down? So remember, we're moving up and down. And so this particle is moving along a vertical line. When would the particle be moving down? Forget about the graph. When is the particle moving down? What would the velocity be if the particle's moving?
When the slope is negative, right?
Negative.
Well, don't think about slope. I'm just saying, think in terms of velocity. When the velocity is blank, if I ask you when is the particle moving down, when the velocity is
Negative.
negative, right? So when is the velocity negative? From here
Between
to here.
1 and
Yeah,
3.
between
Oh,
1
yeah,
and
4.
it's actually 1 and 4 point something, which you
Okay.
could figure out more precisely by actually figuring out the slope. The slope is actually what? 3 plus 5 over 2, 2.5. So that means for every 2.5 that I go up, I must be going up 1. Okay. That means if I go up another 2.5. Okay, I'm not, like, you can figure out the calculation and figure out the actual value, but you understand the concept, right? When is the particle moving down? Now, Zachary, you said when the slope is negative. You would be right if this were showing position and not velocity. Does that make sense?
Yeah.
Okay. Because it's very important. Remember how I was telling you the other day how velocity is the slope of position and acceleration is the slope of velocity. Okay? When is the particle moving up? Go ahead.
If you find the derivative of a position versus time graph, you find velocity, and the second derivative of that is acceleration. But of a velocity versus time graph, then it would be the derivative. The first derivative would be acceleration.
Yes, exactly. That relationship is very, very important. Once we learn about integration, you'll learn more about it. But if you start with a position, you get to velocity by taking derivative, d dt. And from velocity, you get to acceleration by doing d dt. To get from acceleration to change in velocity, you take the integral, which we'll learn about later, integral with respect to time, dt. And then to get from velocity to position, you take integral with respect to time. To get from position to acceleration, you take d second derivative, so second d squared dt squared. And to get from here to here, you just take the integral twice. I don't think there's an efficient way. There might be. I just don't know that. But does this make sense? You just need to know this upper portion. Does this make sense? This diagram right here. This is fundamental. This is very fundamental. Okay. Good?
Yeah.
Okay. All right. So when is the particle moving up then? Basically every other time that we didn't mention. So that's from 0 to 1, this point to 6, right? That's when the particle is moving up. Okay. When does the particle reverse direction? When would that happen? Once again, forget about the velocity, but in general, when does the particle reverse direction in terms of velocity?
When the velocity changes from negative to positive or positive to negative.
Exactly. Okay. That
On
means
the x-intercept, right?
yes. However, here's one caveat though. If it went like this, and then here, that is not changing direction. Okay?
Because it stops, it just stops.
Yeah,
right?
yes. It just
Is that
pauses
just
for a second and then it pauses for a second and then goes back in the same direction. Okay? So the only time that happens is when it crosses the x-axis. So when does it reverse direction? I think it's pretty obvious, at 1 and then at 4 point whatever number that is. Okay. When is the particle moving at a constant speed? What does constant speed mean?
Acceleration is 0.
Constant speed, no. Constant speed means, oh, sorry, you're absolutely right. Acceleration is 0. But in terms of velocity though, what's true about the velocity?
The absolute value of the velocity is, or the
It's the same, right? It's the same over an
it's
interval.
the same.
So
I was thinking
I
in terms of acceleration.
the only time that happens is here, right? From 5 to 6. You can't think in terms of acceleration. When acceleration is 0, that means that the derivative has to equal 0. And we know that the only time the derivative equals 0 is from 5 to 6. The particle is moving at a constant speed from 5 is less than, t is less than or equal to 6. Okay? All right. And the reason why 5 is less than is because here we can't calculate the derivative, but at 6, it's continuous because it includes that point. Okay, so that's why it's less than or equal to. All right. When is the particle moving at its greatest speed? Now this is important. It's not asking for velocity, but when is the particle moving at its greatest speed? What does that mean? Rishi. Exactly. Go ahead.
Oh.
No, you're right. You're right.
Whenever it crosses the most amount of distance in the least amount of time.
Okay, let's think a little bit more broader. In terms of velocity, when is the particle moving at its greatest speed? That's what I wanted to do.
So wait, it's asking in terms of speed, right?
Yes.
So in terms of speed, that must mean that it has to be the farthest distance away from the y value. It must be the farthest distance away from 0.
Yes. Yes. So in other words, the absolute value of the velocity must be the greatest, and the only time that happens is when the y value is furthest away from 0. And when does that happen? That happens at this point right here, at x equals 3, or t equals 3. I mean, you see that? Because it's the absolute value. Even though the velocity itself is greatest here, the speed is greatest here. Whereas if this had continued on for up to here and then turned, then this would have been the greatest speed, because this is the further distance away from 0. Does that make sense? Okay, all right, I'm gonna assume it does. When is the particle, okay, we did that. When is the speed increasing? When is speed increasing?
After 3, after x equals 3. Right? From 3 to 5.
And also from 1 to 3. From 1 to 3, and then from like 4 to 5.
So speed is increasing when
the slope is positive, right?
Well,
because then
velocity is increasing.
Bigger.
Hold on. Velocity is increasing when your velocity would be increasing when your slope is positive, right? But that doesn't necessarily mean, so okay, we'll end in 10 minutes. We'll finish our session in 10 minutes. Here's a caveat though. What you have to realize here is that this is negative velocity. This is negative velocity. So if I were to graph speed, this would actually look like this. And then this is going -2.
The speed would increase, right?
Yes, the speed would increase.
But the speed would decrease from 3 to 4, right? Because it's like, it's the absolute value is getting smaller.
There you go. This is what speed would look like. Because this is what the speed would look like, guys. Do you see what I did?
Yeah, you just undid the derivative of basically.
No, I did not undo the derivative. Undoing the derivative is called taking the integral, and that's called taking the antiderivative, and that's something we haven't covered yet. What I'm doing here is anything below 0, I'm flipping it up so that it fits our, because remember, speed is absolute value of velocity. I just took the absolute value of this function. Does that make sense?
Oh yeah, okay. Yeah, it makes
So
sense.
the speed is increasing anytime the slope is positive when I do this. So you have to do this out, because otherwise what happens is this looks like the slope is decreasing. Yes, and the slope is decreasing, but that's for velocity, not for speed. So
Because that accounts for direction also.
Yes. So if you just want to be able to look at velocity and not speed, then when velocity is negative and decreasing, then speed is increasing. So when velocity is negative and decreasing, speed is increasing. When velocity is negative and decreasing, speed is increasing. But then when velocity is negative and then increasing, the speed is negative. Because why? Do you see that? Velocity is negative from this region to this region, but the velocity is increasing. So that's why the speed is negative. You see that? Oh, sorry, the speed is decreasing. I'm sorry. Does this make sense, what I'm saying? Or no?
Yeah.
Yeah.
Okay. So when is the speed increasing then? From 1 to
3
3. Yep. And then 4 point whatever that number is to 5. Okay, good. All right. When is speed decreasing? Same logic. When is speed decreasing? Just the other times that we didn't talk about. So that's from 0 to 1, 3 to 4 point whatever that is, and that's it. All right, and now let's graph the acceleration. Okay, let's go ahead and do that. Okay, acceleration is what in terms of velocity?
The derivative of the velocity.
The derivative of velocity, good. The rate of change of velocity. Okay, so what's the derivative from here to this portion? The slope is minus 2 over 1 minus 2 over 1. So the derivative here is minus 2, up to 2, right? Up to 2, it's minus 2. Does that look right?
Yeah.
Okay, what about from here to here? What is the derivative here? It's minus 1, right? Minus 1 over plus 1, so it's minus 1 here. Okay, now this is a style choice. I like to keep these separate, and ideally these would actually be open holes. These would be open holes because the derivative is not defined at x equals 2. But sometimes in AP Physics, what you'll see is they'll connect this using a line. In a physics course, often they'll connect this using a vertical line. And that kind of tells you that the derivative isn't defined there. But for the sake of a math class, I like to not do that because, I don't know, it just feels weird. It doesn't feel right to do that. And then from here to here, what's the derivative? 1, 2, 3, 4, 5, 6 over 1, 2, 6 over, wait, that doesn't seem right. 1, 2, 3, 4, 5 over 2 is 2.5, right? So this would be from 2.5 from 3 to 5, right? And then at 5 to 6, it's just 0. Okay. You see, this would be the acceleration. Does that make sense?
Yeah.
Okay. All right, good. Where is acceleration the greatest? I think that's pretty obvious. The greatest at from 3 to 5, right?
Yeah.
Okay. And then are there any more parts to this question? No, that's it. Okay. Does that clarify some of the particle motion stuff?
Yeah, definitely.
All right. How much time do we have left in this meeting? Like 5 minutes. Okay. Any last questions? Do we want to try another on another one of the particle motion problems, or do we want to end? Either way is fine.
Yeah, let's do another problem.
Okay, let's do another. Good. Let's do this one. Okay. Okay, at velocity, okay, so if time is 0 and velocity is -3, is the particle moving to the right or left? Shout out your answer.
Left.
Why? Because velocity is negative. Good. Is there time during the interval 0 through 12 when the particle is at rest?
Yes.
Roshi, do you want to explain this one? You talked about the intermediate value theorem.
Oh, no,
you know
wasn't
that
that
theorem?
for D though? That was for D.
But you can actually use that reasoning here as well.
So so when the particle is at rest.
Particle is at rest means what about the velocity?
It would be 0.
Velocity equals 0. So if we can find a point where the velocity equals 0, we can prove that
So
it's at
it would be
rest.
between time 0 and 2.
And why?
Because it would have to cross 0 from
Okay.
because of the IVT. Okay, yeah, that makes sense.
This is called the intermediate values theorem. Okay, this is one of those fundamental theorems you need to know for AP calculus. If I tell you that the function is continuous, because it's differentiable, we know it's continuous. If I have a continuous function from one point that's positive to another point that's negative, and I know for sure it's continuous, it has to. I mean, just think about it logically. It has to cross the x-axis. It has to equal 0 at 1. However, if it's non-continuous, then there might be a hole, but because they're telling us that it's differentiable, we know it's continuous over there. Does that make sense? Okay. For part C, use data from the table for an approximation of v prime of 10. So for v prime of 10, I can just do, to find, v prime of 10, I can just do 5 minus 7 over 12 minus 8. And that'll be in meters per minute squared. Okay? I'm not going to calculate that, but you get the idea on how to do it, right? That's called a difference quotient. Difference quotient is just like taking the slope. All right. And then genius question, is there guaranteed to be a time such that the acceleration equals 0? Is there? If you take the individual, if you take the rate of change between this point and this point, I think there's a point where it will equal.
Yeah, there is. There
is. Okay. So what you do is you take the average changes in velocity, and because it's continuous, you know that it'll equal 0 at one point. Okay.
Yeah.
And I think that that might be that I think you can actually use intermediate values theorem for that as well.
Yeah, this is the one where I used it as well.
Okay. All right, good. Does that help, Zachary?
Yeah, no, I think I have a pretty good understanding of it. I was just to get another.
Oh yeah, of
practice
course.
problem.
No, that's great. Just to always get that extra practice in. Okay, we have about 1:30 left. These really try and do these. Try and do these like just like just do them rapid fire. Just answer them as quick as you can, and that's when you know that you've understood this. Because when you understand, like originally, you shouldn't be memorizing these. If you're memorizing this, that's not the proper approach. You should be conceptually thinking about it, but you should get so good at quickly conceptually thinking about it that you should be able to answer these real quickly. If velocity is negative and acceleration is positive, then speed is decreasing, right? And I know that because I visualize it as acceleration is positive, velocity is negative. They're in opposite directions. They're fighting against each other, so speed is negative. All right. I'm not going to do the rest of them just because we're running out of time. But that's pretty much it. If you have any more questions, once again, just put it on the Slack. And I will put these recordings on the YouTube channel if you need to go back. All right. Thanks for attending. If you want to fill out the CAS hours, go ahead and do that as well. You're welcome to claim CAS hours for this.
Where's the thing again? The form?
It's pinned on the channel, the Slack channel. All right.
Which one? General?
No, the IB Math AAHL. It's revisnoweducation.wixsite.com/chapters/class of 2022. It's in there. It says chapter link. All right, so this is going to automatically end in a bit. So bye, guys.
Thanks,
Bye.
MG.
Yeah, no problem.
Yeah, thank you.